Hello, welcome to day 2 of transformations. Okay, today there's our transformations. It's a little review. A is amplitude, only on sine and cosine graphs. All right, it's a vertical stretch on the other 4. B determines the period. It's 2 pi divided by b for sine and cosine. Pi divided by for tangent, cotangent, secant, cosecant. All right. Vertical displacement is shifting up and down, and C is shifting horizontal back and forth. Okay, this one's going up and down. And you have to remember to factor out your B. All right, we put some steps together, things to do. Is look at it and think about what the transformations are. You don't necessarily have to write them down. Shift both axes to get the new origin. So you're going to do your horizontal and vertical shifts. Then worry about your new period. And then do the phase shift. It says mark the end of the first period and divide into 4 parts. Why 4 parts? Because of the unit circle, okay? We know those 4 points. So in the sine graph, it goes whoop. We know these are the key points to graph it, all right? So you look at your vertical stretch and do that and then sketch it. So I'm going to look at this. First thing I see is these are together and I have to pull out the 2. So you get the cosine of 2x minus 3 pi. So the cosine graph starts here. I'm going to shift it to the right 3 pi. So here's 1, this is 2 pi, and 3 pi, because 3, okay? So here it is. So this point is no longer there. Now, my period is being changed because I've got a b value. I've got a b value right here. So 2 pi divided by 2 is equal to pi. So it's going to take pi radians to repeat itself. So between here and here, it's got to be at the top. And it has to be at the bottom. So it has to go down, go back, and come up. By the time I get to 4 pi, it's got to do it again. It's got to go down and come back up. So the question is, from here to here, it's going down. If this is pi, this has got to be 3 pi over 2. This has to be what's in between 3 pi over 2 and pi. So you're right, between here and here. That's 5 pi over 4. So that's 5 pi over 4. All right, so there's my graph. Because you know it has to go from top to top in pi units because we changed that. Now my domain is still all reals, and I didn't do any shift, so this is still going -1 to 1. That's not too bad. I can do that one. All right. Now, let's do this while I'm here. Because one of the questions on your test asks you, so what's this? This is pi over 2. Asks you to write a sine function with those same transformations. Now remember, a sine graph, the normal sine graph starts at 0. Okay, well, this one starts right here. So let's change colors. My sine graph would start here. Well, where is that? That's 3 pi over 4. All right, so to write this as a sine graph, I'd say sine, the period's still there, so the 2's still outside in x. And instead of shifting 3 pi, I'm only going to shift it 3/4, 3 pi over 4. Okay, so this graph is the same as this graph. Just kind of neat. We're going to practice that every time. All right, what happens here? I'm going right pi over 2 and down 1. The sine graph starts here. So I'm going to go right pi over 2 and then down 1. So that's the new dot. So I have to erase that one or I get myself confused. So this is at pi over 2. Dang it. Pi over 2. There's no b value, so it's going to take 2 pi. So pi over 2 plus 2 pi. Well, 2 pi is, what, 4 pi over 2, right? So I get 5 pi over 2. So down here at 5 pi over 2, it has to be back to the beginning. Well, halfway in between those is 3 pi over 2. So it has to be there also. So not there. Now, so my graph starts here and it's going to start here and it's going to go up and then it's coming down and then it goes up. The question is how far up? Well, it goes up 4. Well, now remember I shifted down here to -1. So this is 1, 2, 3, 4. Except it's 1, 2, 3, 0. 1, 2, 3. There we go. That makes sense. And 1, 2, 3, 4 down here. So that's -5. Maybe we should change our scale. Okay, so it's going to go up here, come down, go down here. This is now at 3, and this is now at -5. And halfway between these two is pi, and halfway between here is 2 pi. Crazy, isn't it? All right, so let's get rid of that. Ugh. Challenge tonight is real. Okay. So my domain is still all reals. My range is now going from -5 to 5. If I want to write this as a cosine graph, it's still getting stretched by 4. The period didn't change. But instead of shifting it right pi over 2, I shifted it over to 3 pi over 2. And it still goes down 1. So our difference is this between the graphs. Okay, and where do you shift it? Where do we start? Good practice. All right, let's do the tangent graph. Okay, we didn't change the period. We moved it up 5, and then we multiplied by 2. So the thing is, if I plug in 0, this is 0. 0 times 0 is 2. If I plug in pi over 4, you get 1. 1 times 4 is 2. So it's up there at 2. My asymptote is at pi over 2. This one's over here at -pi over 2. If I plug in -pi over 4, I get -1 times 2 is -2. Now it says shifted up 5. So 0 goes up here to 5. 2 goes up to 7. That's 7. This is 5. This goes up to 3. And your graph is doing this. It shifted. But my domain is still all values of x such that x cannot equal pi over 2 plus pi k. And the range is still all reals. Okay. This one hurt my head. I think we'll come back to that one last. Let's do this sine function with everything done to it. Okay. So I'm going to shift it over pi and up 2. So I start here. And I'm going to go over to pi. Let's go to pi. Let's back that up a little bit. Here's pi. Here's 2 pi. Here's 3 pi. Okay. Here's 1. Let's make our life easy. So it goes over pi and up 2. 1, 2. So my center line of my graph is now here. So when I do amplitude, it's away from that line. So I'm at pi. Now my period, went 2 pi divided by 2 has turned into pi. So from pi to 2 pi, it has to go up and back down. So it's going up 3. So I started at 2, so it's going to go up to 5 and down to -1. Okay, so this is 3 pi over 2. Interesting, isn't it? And since it happens in pi, you know it's going to come back here. So it could have started here, gone up, gone down to here. And this is what? If this is pi, that's pi over 2, that's pi over 4. So when I write it as a cosine graph, the 3 stays, the cosine stays, the 2 stays, the 8 is there. But instead of moving over pi, we're moving over pi over 4. And you still went up 2. Okay? Know how to do that. You have to be able to write a cosine and sine function for the exact same graph. All right? All right, that was fun. So let's go back, and I'm going to skip the cotangent. Let's do this cosecant. I'm going to come up here because it helps me. The cosecant is the reciprocal of the sine function. This is at pi. This is at 2 pi. This is at 1. And down here. All right? Now, it's going to shift down 2. But we got to take care of this first. When I put in my pi over 2, at this point, this was 1. And then I'm going to multiply it by 2. So 1 times 2 gets me to 2. And then you shift it down 2, so it's right here. All right? It's complicated. And this one was at -1. And you multiply it by 2, you get to -2. And so it's down here. And now I've got to be able to label my asymptotes. I took 2 pi and divided by 4. So the whole thing is pi over 2. That means this is pi over 2. And this is pi over 4. So my domain is all values of x such that x cannot equal pi over 4 plus pi over 2k, because the period changes. And my range is negative infinity to -4 and 0 to infinity. That one hurt my head. And if I think about this, because I didn't shift it yet, if that was pi over 2 and you put it in here, you get 2 pi. Oh, that works. Is that pi over 2? It is pi over 2. If I plug in pi over 2, you get 2 pi. And the cosecant at 2 pi is 0. And it would be an asymptote. So there you go. Sure enough, it was. And this is pi over 4. And we're plugging pi over 4 into there. Pi over 4 times 4 is pi. The cosine of pi is 0. Yep, that works. There you go. And let's do a cotangent because it shifts the asymptotes. Okay, cotangent parent graph. They're at pi and 2 pi. And the graph goes this way. Okay, so I'm going to shift it left, pi over 3. So this asymptote went over here to pi over 3. And this one went over here to 2 pi over 3. And then my dot went down 2. So that's not doing anything except shifting the graph this way. My period stayed the same. So my domain is all values of x such that x cannot equal, this is negative. So let's start at 2 pi over 3 plus pi k. And my range is still all reals. All right, those are tough, but practice them.